Welcome back to your 2D platformer. To recap, right now we have two platforms set up, a player, and an idle animation looping when we play our scene. Now we can set up the rest of our animations, create a simple 2D platformer movement for our character, and then program those animations to play with the movement. First, I'm going to start by importing my Run sprite sheet. I'm going to right-click, import new asset. Then I'm going to find my Run sprite sheet. I am going to set its sprite mode to multiple, and then I'm going to apply it. Then I'm going to open up the sprite editor. We are going to click the top left slice drop-down menu, and our type is going to be automatic. Click slice. Now we are going to go to our very first sprite here. We are going to find the height and the y axis values, and we're going to paste them along the rest of the cuts. That way we can keep everything oriented during the animation. I'm going to press Ctrl C, and just any sprite that doesn't have a y value of 61, I'm going to change to 61. It looks like it's just going to be 2 frames. And now that is out of bounds, but we are going to change the width as well to 540. Excuse me, we are going to change the height as well to 540. Copy the height value and paste that among all the other cuts. I just noticed that this one isn't 61, so I'm going to change it. Now we have all those oriented correctly. And I'm going to do the same tip as we did before. I'm going to find a place that we can rely on for our pivot point and switch all of the cuts to have the same pivot point. In this case, since we all have the same height for our images, I'm going to choose the bottom. So changing my pivot to bottom center. Now let's click Apply at the top right and exit out of your sprite editor. Now I'm going to click on my player game object. I'm going to go to my animation window, and I'm going to add a new animation by clicking this drop-down menu where it says idle and selecting Create New Clip. I'm going to make sure I'm creating this inside of my animations folder, and then I'm going to name it Run. Now, let's press the record button. And then drag the first frame of your running sprite to your sprite area in the sprite renderer. Notice how we are floating a little bit. That is because our collider is still the same as it was before. So what I'm going to do is I'm going to make sure that the recording button is still selected, and I am going to change the box collider size. If we change our box collider size and offset in our run animation, we want to make sure that in our idle animation we add that property as well. Otherwise, when switching back from the run to the idle animation, we will keep that same shape of box collider and it won't be what we need. So click Add Property, Box Collider 2D, Offset, and then we'll add property Box Collider 2D Size. Now let's go back to our run animation, and I will go to one frame in. Make sure my recording button is pressed. We won't need to change the box collider anymore. All we will need to do is change the sprites. So I am going to quickly change those. Alright. Now scrubbing along that looks awesome. But I want to press play so we can see what it actually looks like. Yikes, that is way too fast. I am going to click the end of this gray bar down here and drag it out so that my view can show more keyframes. I'm going to do the same for the other side, and then I'm going to box select all of the frames and pull to extend the time. Now let's press play. Still a little bit too fast, but better. Now I'm going to go in and manually space it out. I can use my box select to help me move large sections over. And I'm going to separate everything by 5 seconds, or 5 frames. I believe it's 5 milliseconds, actually. So each frame is separated by 5 milliseconds. Alright, let's press play again. I'm going to scooch the animation window back. This is perfect. I'm going to go to my animator, right click on run, and set it as the layer default state, just because I want to see what it looks like when the collider and gravity is affecting our player. Looks like we've got a little bit of a jump there. I don't know if that is because of the animation. Oh, it is? It looks like I forgot 2 frames right next to each other, so be careful that you aren't accidentally forgetting about a frame. Oop, excuse me, that is for my idle animation actually. It doesn't happen every time, so I actually think that it might be Unity's editor that is lagging there. I'm going to continue on. I'm going to go back to my animator, make sure that my idle animation is my default. Now let's click on our player and create a script. Add a component in the inspector, and we're going to name it player controller. Now open up that script so that we can edit it. We aren't going to connect our animation to our movement first. First, we are just going to get the movement squared out, and then we are going to add the transitions to our animations. We are going to start our player controller script by adding variables underneath the public class. I'm going to type public float speed. If you want more information or for me to move slower and in more depth about the player controller script, please see tutorial number 1, simple 2D platformer movement. In order to get you through to the animation programming, we are going to try to do this a little quicker than we did in that video. So please, if you find that I am talking a little bit too fast, make sure you review that video and come back. After public float speed, we want public float jump force. And then we want private float move input. Then we're going to want a private variable for our rigid body 2D component. And I'm going to call that RB. Now we are going to add in our start method RB equals get component. Inside of the angle brackets, type rigid body 2D, and then 2 parentheses. That stores our rigid body 2D in our RB variable. Now we are going to create a fixed update function in between our start and update functions. Void fixed update. Then we are going to set up our input move input. We're referencing the move input variable and storing our horizontal input inside of here. Move input equals input dot get axis. We are going to be trying to get the horizontal axis, which is the A and D keys, or the left and right arrows. In parentheses and in quotation marks, type horizontal. This line is going to return a float that is going to be stored in move input. If you press the left arrow key, it's going to move input is going to equal -1. If you press the right arrow key, move input is going to equal +1. Now we want to change our rigid body's velocity by typing rb.velocity equals new vector2. For your x position, it's going to be move input times speed, since we're moving left and right, and that is the x-axis. And then for y, we are going to just type rb.velocity.y and end that line with a semicolon. Now let's save, and let's test our scene. Make sure you type a speed inside of your player controller script component. I'm going to type 25 just to start out with. And now let's press play. Ooh, whoa. That's real fast. A couple things there. We rotated in a way that we didn't want to. And we were also very fast, so I'm going to change that from 25 to 5. Now I'm going to go to my rigid body 2D component, and I'm going to freeze my rotation by the z-axis. Let's try again. Very good. We can move left and right. But notice that we are always facing the right direction. We need to make sure that we are flipping directions when we are going the opposite direction. Let's go back to our script. We are going to add one more variable under our public class, and that is going to be a private bool called facing right. This is what we're going to use to keep track of whether or not our player is currently facing towards the right. And that is going to start out as true because we are always facing right to begin with. Now we're going to scroll down, and under our update function we are going to create a new function, void flip, and open it up with squiggly brackets. The first thing we're going to do is take the current value of the facing right bool and change it to the opposite value. To do that, we are going to say facing right equals. Then we are going to use an exclamation point, and in this case, the exclamation point before the variable is going to set it as the opposite value. So facing right, if facing right currently equals true, this exclamation mark before facing right means false. I'll put a semicolon at the end of that. And that is going to toggle facing right to true or false whenever flip is called. Now we're going to create a vector 3 called player scale, and it's going to be equal to our current transform dot local scale. Next, we're going to want to take that scale by the x-axis player scale dot x, and we're going to want to multiply that value to the current value by -1. What that means is if player scale dot x currently equals 4, take it and make it equal -4. So it's just going to have the opposite value. What that does is flip your sprite. Under that, we are actually going to update our transform.local scale by typing transform.local scale equals player scale, which is our new variable that holds our new scale. This function is going to successfully flip our character. Now we need to create the conditions in which our character flips. And we will do that in our fixed update underneath rb.velocity equals new vector 2 move input times speed and rigidbody.velocity.y. Underneath that line, we are going to write our new line. Start an if statement by typing if and then opening up parentheses, and inside say facing right equals false, then type 2 and symbols. They're also known as ampersands, and that means and. That means that this if statement will only be fulfilled once both of these conditions are fulfilled. So if facing right is false and move input is greater than 0, like I said before, move input when it equals 1, it means you are pressing the right arrow key. When it equals -1, it means you are pressing the left arrow key. So if it is greater than 0, that must mean we are going right. But if our facing right bool equals false, that means we were previously facing left. So this is going to trigger that flip. If our facing right bool is false, but we are in fact facing right, then I'm going to open up that if statement and type flip. It's simply calling to that method. Under that, I'm going to type else if facing right equals true, and double and signs, move input is less than 0. You also want to call to the function inside of there. This means essentially the opposite of the if statement before. It means or if the facing right boolean does equal true, but our move input is less than 1, which means it's -1, so we're moving to the left, then flip, because we have not flipped yet. Let's save this script and go back to our project and press play. Very good. So now we flip back and forth. Now we're going to give our player the ability to jump. Under your public class, let's declare a few more variables. Let's type private bool is grounded. Under that, let's add a public transform called ground check. Next, a public float called check radius. After that, public layer mask what is ground. And then a couple lines after that, I'm going to type private int extra jumps, and then public int extra jumps value. Our private bool is grounded is going to keep track of whether or not we are on the ground currently. That way we don't have our player having unlimited ability to jump and double jump and quadruple jump unless we mean them to. Our public transform ground check and public float check radius. Those are two variables that we are going to use to see whether or not we are close to the ground. And then our layer mask what is ground is going to tell us exactly what is the floor and what isn't. Private int extra jumps is what we're going to be using to keep track of how many extra jumps we grant our player. And then the public int extra jumps value, that is where we are going to set the value of our extra jumps in the inspector. The first thing I want to do is in our start function, set our extra jumps equal to extra jumps value. Like I said before, that's just going to guarantee that the value of extra jumps is the max value of extra jumps we set in the inspector. So if we want to give them the ability to double jump, we are going to set extra jumps value to 1, giving them 1 extra jump. And here extra jumps is our counter, which is being set to that value. Scroll down to your update function. First, we are going to start with a if statement. If, in the parentheses, type input dot get key down, key code, in parentheses after get key down, type key code dot up arrow. Then I am going to type these two symbols. They are just vertical lines. For me on my keyboard, they are right above the enter key. it shares the backslash key. You just need to hold shift and then press that backslash key above enter, and it'll give you these vertical lines. Type two of them next to each other. That means or. Just like these two and symbols mean and, this means or. So either if we get the input of the up arrow, or I'm going to grab this first part and copy it and then paste it. And instead of having up arrow, we are going to type W. Then we're going to open up that if statement. We're not done with the condition of this if statement yet. Now we want to surround this entire chunk in parentheses. So a beginning parenthesis at the beginning, end parenthesis at the end, and then before the very last closing parenthesis here, we are going to type and, two and symbols, extra jumps is greater than 0. So now, this if statement is listening for input, either the up arrow or the W key, and it also wants to make sure that we have extra jumps that are greater than 0 right now. If we are at 0, we don't want to continue with this if statement. In that if statement, type RB dot velocity equals vector2 dot up, and that's going to send us in an upward direction, times jump force. And then under that, we're going to type extra jumps with 2 minus signs afterwards. That's going to subtract from our extra jumps by 1. I'm going to copy that if statement, type else after that if statement, and then paste. So now I have an else if statement that begins the same way, except for I want to change this end part here. Instead of saying and extra jumps is greater than 0, I'm going to say and extra jumps is equal to 0. Make sure you have 2 equal signs. I am also going to put 2 more and symbols, and then is grounded equals true. Now I'm going to get rid of extra jumps minus minus. We don't want to get rid of any of the extra jumps because at this point we have no extra jumps. This is our last jump here. I'm going to press Control S. Now above these two if statements, we are going to type another one. It's going to say if is grounded equals true, extra jumps equals extra jumps value. So we are just doing the same as in the start function, resetting extra jumps every time we hit the ground. Now let's save and go back to our Unity scene. We need to do a couple more things before continuing with our code. First, we need to click on our player game object, right click, and create an empty game object. Name that empty game object ground check. We want to click this cube symbol here, open up that drop down menu and select an icon. Now you just want to make sure that that is at the bottom of your sprite. So right now, it looks like it definitely is. And we can save and continue. Go back to your code. Let's go back up to fixed update. And at the very top, let's write a line that says, is grounded equals physics 2D. So we are reaching inside of the physics 2D library. Dot overlap circle. This is basically going to create a circle and return whether or not it was intersected. Let's open up parentheses there, and we want to type ground check dot position, which is that game object that we just added. We still need to set it in the inspector, but we'll do that right after we type this. Separate that with a comma, then type check radius, separate that with a comma, and then type what is ground. Now let's go back to our Unity scene. We need to change our jump force to 5. And we need to take our ground check game object and drag it here to set it in the inspector. As you can see, we have a transform icon here. So the transform of our ground check item is what is in that variable. Next, we want to change our check radius to 0.5. And now we want to create a layer mask. Click on platforms and then click on the individual platforms inside. I'm going to just select the first floor that we created for now, and then go to layer where it says default, open up that drop down menu and then click add layer. Where it says user layer 8, I'm going to type ground, and then I'm going to click back on this floor and set that ground layer as my floor layer. I'm going to do the same with floor 2, and we'll just make sure that we have any platforms from now on containing the ground layer. Now let's go back to player, scroll down, and next to what is ground, click the drop down menu and select ground. Now let's save and press play. Very good. So now we jump, but we don't have any extra jumps. I don't have the ability to double jump. To change that, we go to extra jumps value in the inspector, and we'll change that value from 0 to 1. Now if I test, I have the ability to double jump. And let's see if I can get across this platform. Very good, much easier with a double jump. If you wanted to, you can add as many extra jumps as you want. I'll add 5, and that'll make me very airborne. There we go. So for now, we've got a really good basic platformer movement. We can move side to side, and we can jump. We've also learned how to create a double jump system, and that is very flexible, so we can change it whenever we want to. If you wanted to add power-ups that changed how many extra jumps you had, that would be a great game mechanic. For now, we are only doing our idle animation during these movements, but in the next video we're going to go over more about programming the different animations with our movement. Thank you and have a wonderful day.